So hello everyone, today we are going to understand about representation of sinusoidal waveform. See, in AC voltage or current, normally in a grid we have the voltage and current which will follow the sinusoidal fashion. So that's why it is really important for us to understand that how exactly the sinusoidal function varies when the theta changes and how it is related with the AC waveform. So if you go with mathematical expression of sinusoidal waveform, so it looks like this. So this can be I, means instantaneous value of current I can be given as multiplication of maximum current of maximum value of current in multiplication of with sine omega t, and where omega t is the theta, the angle. So where this concept comes actually, so when in a generator the angle varies, so with the change in the angle we have a voltage in the output. So if we have, let's say, two number of poles, so when mechanical angle varies from 0 to 360, so in proportion to this angle we have voltage also which varies with the sinusoidal fashion. So my voltage will also varies like this, so 0 and 180 degree and 360 degree. So here this voltage is having some angle, and this is something known as an electrical angle. So the output voltage, if you just observe its angle, its waveform, so this is electrical angle, and mechanical angle is something where the generator having is it's one revolution. So when we have two number of poles, so mechanical and electrical angle will be same. And let's say if we are having four number of poles, so while actual generator rotates from 0 to 360 degree, so at that time we have in the AC, if we look at the, if you observe the AC output voltage, so it will complete two AC cycle. So we know that electrical angle is like 0 here and 180 here, 360. Again new cycle will be started, so again 360. So let's say if we consider 0 here, again 180 and 360. So it means in a one AC mechanical rotations of any generator, we will have two AC cycles. So it means that the electrical angle is twice than the mechanical angle. So it depends upon the number of poles. Now this is about the rotation. So uh, here it is also important to notice that this angle, like the changing of the angle, may be too fast also, may be too slow also. So here it is also matters that in what time this one revolution get completed. So say for example, if my one revolution in case of two pole machine get completed in, let's say, 20 millisecond, okay, so it means that my angle will change from 0 to 360 degree in a 20 millisecond. Okay, so here also if I just reproduce the timing, so in 20 millisecond I will have a 360 degree electrical angle, and 180 degree I will have this 180 degree angle, electrical angle, in 10 millisecond. Say for example in this 4 poles machine, if my mechanical angle changed from 0 to 360 in 20 millisecond, so in this case here I will have 20 millisecond, and this one cycle will take 10 millisecond. So here, and in this way we will have a difference in the timing, here 0 millisecond. So in short, here this one AC cycle get finished in 20 millisecond. So this is something known as a period of the signal. Here it is 20 millisecond. Now here my period will be half of the previous one. So my period will be 10 millisecond. Okay. So let's say if I rotate my generator in a slow manner. So say for an example, if I have this generator, and if I am running two pole machine and I am rotating from 0 to 360 degree in, let's say, 1 second, so it would take 1 second to complete one AC cycle. So this timing will be 1 second. Okay, so this is like 0 and 180 and 360. So one AC cycle will get finished in 1 second. So the period of this AC cycle would be 1 second. Okay. Now again, after completion of one revolution, what we will have next? Again the second revolution. So if I am completing each revolution in 1 second, so each electrical AC cycle will get finished in 1 second. So that's how my period is 1 second. If I am finishing the one revolution in 20 millisecond, so I will have one AC cycle in 20 millisecond. Okay, so my period would be 20 millisecond. If I have 4 pole machine, even I am rotating it from 0 to 360 degree, I will have a 2 AC cycle. So I am rotating in 20 millisecond from 0 to 360 degree, but I will produce here electrical angle 0 to 360, and then again another one AC cycle which is again 0 to 360. So in a complete way this angle is 720 degree. So in short, this one cycle would in order to complete one AC cycle, I will only require 10 milliseconds. So in this way, I will have a sinusoidal voltage in the output. And why the nature of output voltage is sinusoidal? This is due to the electrical generator, because while you change its while you rotate it, so it will produce the AC output voltage like this. If we just go into the definition of period, so period is something that signal repeats itself which a specific interval of time, which is something known as a period of a signal. So say for example, if we understand various examples. So first example, if I am having signals like this, okay, and this particular, so if I am starting from here, then when I progress in this direction, so I have positive peak, then again reach to 0, the negative peak, and again come to 0, then again my positive cycle gets started. So this is the point where my positive cycle gets started, and this is the point where my positive cycle gets started. So this is the specific interval. So which will be the specific interval? This one, after which signal starts its repetition. So this would be my period. Say for example, if it took 1 second here, then again 1 to 2. So in this case, this signal is taking 1 second to repeat itself. So period of the signal would be 1 second. Let's understand it with the another example. So say for an example, if I am having a waveform like this. Okay, now let's say this is my 0.5 second, and this is again 0.5 second. Okay, so here this is the point where my positive cycle gets started, it reached to peak, again it reached to 0, and again my next positive cycle gets started. So my signal is having repeating sequence after this 0.5 second. So this is the duration, actually 0.5 second. So here my period would be 0.5 second. Okay, so period is something where you have to understand that after what time period my signal is repeating. If I explain you with the another example, say for example, if you are having square wave like this, so this is the, let's say, 0.8 second, and this is, let's say, 2 second. Okay, this is again 2.8 second, right? And later the signal will get repeated. Now if I just observe this signal, so here it started with 0, it has some peak value, okay, then it gets settled on this value, then again back to 0, and from the 0.8 second to 2 second its value is 0. So that's why we don't have any signals. So from this point to this point I don't have any repetitions of the signal. So my signal get only repeated after this particular duration, which is 2 seconds. So in this way my period would be 2 seconds. Okay, I hope it is clear. Okay, and what is the frequency? So frequency is one of the important term in electrical engineering. So frequency is number of cycles that get finished in 1 second. So here let's say if I write it, the number of cycle uh, get finished in 1 second. So I'm looking for the duration of 1 second. Let's say for this particular example, my one cycle get repeated in 1 second. So my frequency would be 1, and the unit of frequency is hertz, so frequency is hertz. So 1 hertz. Here my signal get repeated after 0.5 seconds, so in 1 second. So this is 0.5 second and this is again 0.5 second. So in 1 second total 1 plus 1 means 2. So my frequency will be 2 hertz. So if I relate this frequency with a period, so frequency is inversely proportional to period. So if I know what is the period of the signal, I need to take a inverse of this. Once I take inverse of this, I will get the frequency. Okay, I hope it is very much clear to you all.